Good day, everyone. I am Manuel L. Cuarez, and me and my fellow researchers are here to present today our thesis proposal entitled The Design and Implementation of Radio-Based Wearable Social Distancing Bracelet. As we all know, the number of COVID-19 patients in our country have been increasing at an alarming rate. Since there is no cure for the infection for now, prevention is the only efficient way to stop the spread of the disease. One of the many ways to reduce the risk of infection is through people limiting physical contact towards each other. Based on this concept, me and my fellow researchers are aiming to develop a device that aids in the proper implementation of social distancing.
The COVID-19 pandemic has brought a lot of challenges to many people around the world since it began in Wuhan, China at late 2019. It spreads primarily through droplets of saliva or discharge from the nose when an infected person coughs or sneezes. People who are exposed to the virus suffer respiratory complications and in some cases can lead to death. With today's population density, the spread of the disease is growing at an exponential rate all over the world, primarily because of unmonitored physical contact and travels of people. Efforts and precautions such as wearing masks and quarantine procedures are being implemented to ensure the containment of the spread of the disease.
Perhaps one of the traditional ways to avoid catching the illness is through maintaining social distancing. Since the droplets produced by COVID patients has a limited range of about 5 to 8 feet, if done correctly, people are unlikely to catch the spreading infection due to the droplets' insufficient infection range and limited physical contact among individuals.
While this may seem like an easy approach to follow, people often forget or neglect intentionally to follow the social distancing precautions. The local government units have insufficient equipment and manpower to further monitor the people's distances towards each other at all time. With this, the researchers propose a way to help people maintain social distancing. This paper discusses the design and implementation of a radio-based wearable social distancing bracelet. These wearable devices functions in groups and enable the wearers to further monitor and adjust their distance in relationship to other wearers, further aiding in the implementation of social distancing protocols. In general, the main purpose of this study is to create a wearable device that prompts users to maintain social distancing in order to slow down the spread of the COVID-19 infection.
Problem statement: the radio-based wearable social distancing bracelet has to overcome challenges in terms of range, portability, and efficiency. In what way should the radio-based wearable social distancing bracelet be designed? What working technological principles should be followed to ensure the device functionality? What methods of evaluation can be used to evaluate the radio-based social distancing bracelet's efficiency in real-life situations?
This paper aims to develop radio-based wearable social distancing bracelets that are able to successfully and effectively prompt wearers to maintain social distancing and design it to be cost efficient and lightweight. Furthermore, listed below are the specific objectives of this study. 1. To design a relatively cost-efficient, lightweight, and user-friendly social distancing bracelet prototype. 2. To figure out the working technological principles that supports the development of this device. 3. To assess efficiency of the social distancing bracelet in real-world situations.
Conceptual Framework. As seen in the presentation, the devices receive input signals from other wearers via antenna. These signals are then processed and translated by a series of operational amplifiers and other electronic components. The translated signals are then interpreted by the wearer by utilizing a combination of output electronic components such as LED and buzzers. Here are the related literatures for this study.
So far, Many countries have used technology-based solutions to overcome the pandemic loss. Several developed countries are employing GPS technology to monitor the movements of the infected and suspected individuals. Provides a survey of different emerging technologies including Wi-Fi, Bluetooth, smartphones, and GPS, positioning localization, computer vision, and deep learning that can play a crucial role in several practical social distancing scenarios. Some researchers utilize drones and other surveillance cameras to detect crowd gatherings.
Georgia Tech researchers have created a custom wearable device that helps users stay safely apart in public places. The device, called 6 Feet Apart, performs wireless localization using ultra-wideband ranges to determine if two or more devices are in close proximity. It can be worn by users or placed on objects in hospitals, schools, grocery stores, and warehouses, and similar locations. Electromagnetic waves in the electromagnetic spectrum are characterized by their wavelength or alternatively by their frequency. Both magnitude are related with the propagation speed of such waves and the speed of light. A 6 feet apart uses ultra-wideband ranges. Radio waves are ideal for estimating distances because they travel at a fixed speed that can be measured. In operation, 6 feet apart invites all neighboring devices to exchange wireless ranging packets to determine distance. Messages are limited, so each round of distance measurements isn't time-consuming. The device's merging of wireless networking techniques and wireless sensing technology also make it more precise than other comparable devices. Instead of alerting a user anytime devices are in range, 6 feet apart can distinguish if there is a physical barrier between devices, such as a wall, that would prevent close contact. It can also observe the received signal and its echoes from nearby objects to determine if there was a human blocking the signals. These prevent false negatives when two people are too close to each other, but their bodies obstruct the signals from their devices.
The social distancing sensor devices that uses ultrasound and radio. These devices demonstrate bi-directional communication and each device buzzer is triggered when two units are in close proximity. The prototype consists of only two devices. More devices could be built to model a real-world application in which each user in a group settings receives such a device. More transmitters and receivers could be added in a different orientation to each device so that a device could detect other units at any angle. Another idea to take this project to the next level is to implement a central system that can connect to all the devices. Its use is an area and monitor clustering and social distancing violation. And that's all.
Enforcing social distancing by developing wearable wristbands that buzz when two employees come within 6 feet of each other. These devices utilize Bluetooth, shortwave, and low-power technology to function.
Wearable magnetic proximity sensors. A study conducted by Bian et al. At 2020 processed a wearable oscillating magnetic field-based proximity sensing system to monitor social distancing as suggested to prevent COVID-19 spread. The researchers have evaluated the system both in controlled lab experiments and in a real-life large hardware store setting. They demonstrated that due to the physical properties of the magnetic field, the system is much more robust than the current Bluetooth-based sensing, in particular being nearly 100% correct when it comes to distinguishing between distances above and below the 2-meter threshold. The aforementioned studies above indicate that the development of our device is plausible. These studies proposes a variety of ways to further implement social distancing efficiently with the aid of technological devices. In addition, majority of the previously mentioned studies are sensor-based and uses a variety of scientific properties such as electromagnetism and radio and ultrasonic devices, which are in correlation to our research objectives, which is to create a portable and wearable social distancing device. With further extensive research, the probability of creating a prototype is guaranteed to increase. Concept design. As indicated in the presentation, our devices consist of two parts, the transmitter and the receiver. The transmitter sends out radio signals that can be detected by other wearers, informing them to maintain a relatively safe distance. These radio signals are then received by the receiver module of the device. The receiver collects these radio signals via antenna and is then translated by a variety of electronic components such as operational amplifiers, transistors, and diodes. The devices produces outputs through different output devices, such as LED. Green LED indicates that the area is safe, and red indicates that another wearer is nearby. It also utilizes a buzzer to indicate their respective distance status in relation to other wearers. As for now, our study is still at its planning stage, and the development of the device requires more extensive research. In addition, upgrades and revisions are still possible in the future. The researchers may consider the utilization of programmable microcontrollers such as Arduino to handle signal processing and output. That is all for this presentation. Thank you.